welcome back. Here we go with another video. This time we're going to be discussing confidence intervals for two means. Now we've talked about how to do a confidence interval for the mean when we have one sample. This is going to be the case where you're trying to compare means of two different populations. In this case, what we do is we collect two different samples. We calculate a confidence interval on the difference between those two population means. All right, this is called a two-sample t-interval. All right. So what are some of the necessary conditions? So we're going to really invoke the central limit theorem, but with one extra condition here, and that is the independent groups assumption. So just like we talked about in the proportion video, the two-sample proportion video, same thing here. We need to have that both of the groups are independent of each other, okay? Meaning, once again, results of one doesn't affect the results of the other. Okay, there's no interdependence between the two groups. All right, that's something where it's not something that we could really check outright, but it's just something where can we just make a reasonable assumption? That's all we really have to keep an eye out for. So that's the independence between the groups. Well, we also need independence within each group itself. And what are the typical ways that we check for that? You guys know the drill. Randomization. Did we collect a random sample? Okay. Even if we weren't told explicitly that the random sample was collected, can we assume that is it reasonable to assume that it represents a random sample? And then also we need to make sure that less than 10% of the population is sampled. If you've been keeping up with the videos, you know that those are common conditions that we've been dealing with. And also for the t-distribution. So remember when we do confidence intervals for the mean, remember we're dealing with the t-distribution, not the z-distribution. Well, for the t-distribution to work effectively, we need to satisfy the nearly normal condition. So what does that say? That says, listen, if your sample size is relatively small, let's say less than 30, then we need to make sure this data forms a normal distribution, right? And that means unimodal and symmetric. So what we do is we look at the histogram, and we say, okay, if you're relatively unimodal and symmetric, we're good to go for small sample sizes. Remember, we have to avoid the skewed data and the outliers. But for sample sizes that are bigger than 30, that are significantly bigger than 30, we're usually pretty good to go. As long as the data isn't extremely skewed. But if the data isn't that skewed, bigger than 30, we're good to go. All right, so once all the conditions have been checked and they are met, then we can perform the two-sample t-interval. Now, what is that? So what we do is, remember, we have two different samples that we're working with. We do x1 bar minus x2 bar. Okay, that kind of gives us our what we call the point estimate, the center of the interval. And then we add and subtract the margin of error. Well, how do we get the margin of error? We take t star, which is your critical t-score, and we multiply it by the standard error. So let me highlight this. This right here, the square root stuff, that is the standard error. Okay? And it takes S1 squared over N1 plus S2 squared over N2 and the square root of that sum. Just in case you need a refresher, remember S1, remember S means sample standard deviation. So S1 is the sample 1 standard deviation. S2 is the sample 2 standard deviation. N1 is our sample 1 size. And N2 is the sample 2 size. All right, so those are kind of the symbols that are involved in our standard error formula. And then I guess while we're at it, remember T star is our critical t-score. All right, but here's the deal, y'all. I know we've talked about the t-distribution before. We said it's based off of degrees of freedom. That is true, and that's still true here. However, in this two-sample case, our degrees of freedom are no longer just n minus 1. Instead, it becomes this monstrosity of a formula. Now here's the deal, folks. It's actually not that bad to implement and use, but here's the deal. We are going to use technology because whenever we use technology, they're going to automatically calculate these degrees of freedom for us. Okay, but if you're interested in doing this by hand, you would get the degrees of freedom from this formula, which is going to give us a decimal. So what you would do is you take that number, whatever it is, round that down. That'll give you a whole number. Then you can go and figure out your T critical based on methods we have talked about in previous lectures. But for this particular video, I'm going to use just technology for this one. If you're curious about how to do this by hand, feel free to shoot me a message. All right, let's see here. I got a little typo here, but let's get into interpretations for the two sample T interval. So let's start off with what it means to be 95% confident. So we know from before with previous confidence intervals that 95% confidence means that in 95% of all confidence intervals created from samples of the population, 95% of all of those confidence intervals will contain the true difference between the population means. So we're saying that this method that we're going about is correct 95% of the time. All right. Also, since we're dealing with the difference between two different populations, we also have these other useful interpretations. For instance, if our confidence interval contains all negative values, so remember, we're trying to estimate mu1 minus mu2. If the interval contains all negative values, that indicates that we are confident that mu1 minus mu2, the population means the difference between them is negative. Which means if we just easily add mu2 to both sides of that inequality, we can also state that, hey, we are pretty confident that the population mean of the first population is going to be less than the population 2 mean. So that's pretty cool there. So if you get all negative values, you can say that we're pretty confident that mu1, the population mean of group 1, is less than the population mean of group 2. And the opposite happens for all positive values, right? What we're saying here is that mu1 minus mu2 is greater than 0, which indicates that we are pretty confident that mu1 is greater than mu2. All right? We'll see applications of this in a second with an example. And then lastly, if the interval contains both positive and negative values, well, we really can't say anything. We cannot make a statement about one population mean being definitively higher than the other. So we can't really make that strong statement like we could in the other cases where we have all negative values and all positive values. All right, let's get into an example. Consumers spend more on a trip to Target or Walmart. Suppose researchers interested in this question collected a systematic sample for 83 Target customers and 84 Walmart customers by asking customers for their purchase amount as they left the store. Using the given summary statistics, calculate a 95% confidence interval for the mean difference between Target and Walmart purchase amounts. Okay. All right, so they have summarized for us in this table here. The N is the sample size for Target and Walmart, the sample mean for Target and Walmart, and the sample standard deviation. Okay. Part A, check the necessary conditions. Always have to check the conditions. All right, so the first condition we'll look at is the independence of the groups, right? The group independence assumption. All right, so once again, it's nothing that we can really directly check, but it's reasonable to assume that Target shoppers are not affecting Walmart shoppers, okay? So because of that reasonableness, let's go ahead and say there's independence of the groups, okay? What about independence within the groups, right? Let's check for randomness. Okay? Once again, that's another one. It's reasonable to assume that this systematic sample, even though it's not random, the systematic sample is going to give us enough of a random sample there, okay? So once again, it is reasonable to assume randomness. All right. Let's talk about the 10% condition. Okay. We need to sample less than 10% of the population. I didn't finish the conditions, did I? Let me go back up here, guys. Let's see here. I'm so sorry. We didn't finish the conditions. Yeah, we did. 3, 2, 1. All right, then we need to check for the less than 10% sampled condition, right? So we have 83 Target customers, 84 Walmart customers. That is way less than 10% of all possible customers from those stores. So the less than 10% condition is good to go. All right, and lastly, we need the nearly normal condition to be satisfied for the T distribution. All right. Well, we don't really have histograms that we can look at here, but we can take a look at our sample sizes, 83, 84. Those are relatively large. So if you remember, our normal condition is if you're large enough, then you can go ahead and safely say that that condition is met. So 83, 84, that's pretty significantly larger than 30. We're good to go. So we have a large enough sample size. Okay? All right, so the conditions are met, so we can find the confidence interval. All right, part B says calculate the standard error. All right, calculate the standard error. Well, as I told you guys, we are not doing this by hand, so we're actually going to come back to this. We're going to fill this in when we do part C. Okay, so part C. Calculate the 95% confidence interval for the population mean difference and interpret the confidence interval. So what we're going to do is we're going to use StatCrunch. Okay, but before we do that, we need to identify what's sample 1, what's sample 2. So let's do this. Let's let Target represent sample 1. And we'll let Walmart represent sample 2. Okay. So the mean for Target is 40 and the standard deviation for Target is 20 and the sample size is 83. So let's go to StatCrunch. Okay, so to get to that, ignore the data. You're going to click on Stat. We're going to go to T-Stats. Remember, we're doing a 2-sample T interval. So 2 sample. And then we're going to select with summary. We have the summary statistics. When they give you the mean and the standard deviation, you have the summary values. Okay, our sample mean. Our sample mean was 40, if you recall, for Target. The sample standard deviation was 20. And the sample size, was it 83 or 84? It was 83. Sample size was 83. Okay. Sample 2 was Target, or excuse me, was Walmart. And they had a sample mean of 52 with a standard deviation of 19 and a sample size of 84. Okay, so be careful how you enter these values in here. All right, calculation options. So when it comes to doing 2-sample T statistics, there's this option of pulling, what's called pulling your variances. The short of it is that if we were sampling from a situation where our population variances were equal, then we would have to do what's called pulling our statistic. Anyways, select no. We're not going to pull. It's safe to not pull your variances, okay? So we are going to just keep that off. Don't check that, okay? All right, what are we performing? We are performing a confidence interval for mu1 minus mu2. Our confidence level is 95%. That's all we need. We're going to compute. And look at that, folks. All right, remember that part B where it asked for the standard error? Let's go ahead and give it to them. It's the 3.019 to 3 decimal places. Standard error is 3.019, where they use that crazy degrees of freedom formula. And then what's the actual confidence interval? Well, it goes from, let's just do 2 decimal places. Oh no, where'd you go? There you go. So our lower limit is a negative 17.96 up to an upper limit of, keeps doing that, stop, negative 6.04. Okay? All right. So what does this mean? Interpret this confidence interval. This means that we are 95% confident that, so once again, remember, this is a confidence interval for mu1 minus mu2. Remember, 1 represents, I forgot myself. 1 was Target, and 2 was Walmart. Okay, notice our interval contains all negative values. So that indicates to us that mu1 is less than mu2. So we are 95% confident that the mean amount spent at Target is between 17.96 and 6.04 less than the mean amount spent at Walmart. Okay? Once again, we're saying less because we have all negative values in our confidence interval. All right. Let's keep it moving. Next one. Businesses know that customers often respond to background music. Do they also respond to odors? One study on this question took place in a small pizza restaurant in France on 2 Saturday evenings in May. On one of the evenings, a relaxing lavender odor was spread throughout the restaurant. On the other evening, no scent was used. The data in StatCrunch gives the time in minutes that 2 samples of 30 customers spent in the restaurant. The 2 evenings were comparable in many ways, the weather, the customer count, and so on. So we are willing to regard this data as independent, simple, random samples from spring Saturday evenings at this restaurant. Okay? So the data that I'm gonna show you in StatCrunch in a second contains, for each of those Saturday evenings, 30 times that the customer spent in the restaurant. Okay, part A. Assume all conditions are met. Find the 95% confidence interval on the difference in population mean times in the restaurant when no odor was present and when the lavender was used. Okay? All right. So what we're going to do here is, once again, identify your sample 1, your sample 2. We're going to let 1 represent no odor. And we're going to let 2 represent when they sprayed lavender in the place. Okay? All right. So with that being said, let's go to StatCrunch and let's take a look. Oh, what's happening here? Oh. Let's take a look at our data set. Get rid of our old work here. And so what you'll see here is the first column is the number of minutes that 30 customers stayed in the restaurant when there was no odor present. And then lavender is the second column, how many minutes they stayed in the restaurant when when lavender was present, being sprayed throughout the restaurant. Okay, so that T-stats to sample with data. Okay, so it needs to know, what's your sample 1? So we said sample 1 was no odor, so we're going to select that as our column for no odor. Sample 2 was with lavender, those minutes, okay? Once again, don't worry about pulling the variances. We're going to do a confidence interval for 0.95 is the confidence level. Okay, everything else seems is good to go. We're going to come down here, click compute. There we go. There we go, folks. All right. So our confidence interval goes from a negative 21.64 to 7.09. So our confidence interval is negative 21.64 to a negative 7.09. All right. Okay, sorry about the technical difficulties. All right, so that is our confidence interval. Okay, so using the confidence interval from part A, does using lavender encourage customers to stay longer? Well, let's look at what will be our interpretation of this, right? Okay, so remember we're trying to estimate mu1 minus mu2, right? Where 1 is no odor, 2 is lavender. So what is the interpretation? So we can say that we are we are 95% confident that the mean time spent in the restaurant when no odor was present is between 21.64 and 7.09 minutes less than the mean time spent when lavender was present. All right, so basically, long way to answer the question. Does lavender help people stay longer? Yes. So the answer is yes. Lavender makes customers stay longer. Okay. All right, so really the big point of this whole video, guys, is I just want you to get comfortable using the technology that's at your disposal, and I hope this helps. I look forward to seeing you all in the very next video.